Dear students, today we will discuss the nomenclature system, that is RS nomenclature. That system is given by the can, relog, inward, relog, CIP, also called as the CIP. This technique is to find out the absolute configuration. Okay, it is type of the absolute configuration, and by using the sequence rule we can predict the whether your compound is R configuration or whether your compound have the S configuration. Let us start with the sequence rule. That sequence rule is also given by the can, inboard and prelog. The rules we will learn one by one. That first rule is to given the priority. Okay, sequence rule. Okay, sequence rule is to give the priority to groups or atoms attached to chiral carbon or chiral atom. If suppose we have a chiral carbon is there and different group is attached there, so for example hydrogen is there, deuterium is there, then Br, and last group is the CH3 group is there. If the groups, different groups is attached to the central atom or chiral atom, then according to the atomic number we can choose the priority. Okay, in this molecule a different, okay, Br is attached, there is the deuterium is there, hydrogen is there, and different groups is attached to different elements, different atoms is attached. If attachment to the chiral, central chiral atom is different element is attached, okay, then by using the simple atomic number we can give the priority. In this case the bromine is the atomic number is higher than other these four compounds. Bromine has the atomic number that is 35, its atomic number. Hydrogen is 1 atomic number, deuterium is the 2, and carbon is the atomic number. Carbon for 6 is the atomic number for carbon. Okay, directly attached to the chiral center is 4 different attachment is there. Okay, in this case Br, hydrogen, deuterium, and 4 different attachments there. Then we give the priority according with its atomic number. Okay, atomic number of the priority of bromine will be 1. Then second for is carbon, third for deuterium, and fourth for the hydrogen. Okay, in this case we have taken the 2 isotopes of the hydrogen. Okay, in this case hydrogen and deuteriums are isotopes to each other. For giving the priority to isotopes, we will consider the which isotopes has the higher mass. Okay, in this case deuterium has the higher mass than the hydrogen, therefore we will give the higher priority to the deuterium than the hydrogen. Okay, the higher priority means the 1 is the higher priority, then the 2 is the higher priority than the 3, and the 4 lowest priority is the 4. 1 is the highest priority and 4 is the lowest priority. Okay, first rule we have learned that if 4 different groups or 4 different attachment is attached to the chiral central atom or stereo center, then according to the atomic number we will give priority to these groups. And if there is isotopes is there, then those isotopes which is having the higher mass, it is considered as the highest priority. This is first rule for giving the priority. Okay, this we have seen the first rule. Now second rule, if your central atom or chiral atom has attached the same attachment is there. Okay, in this case Br is different, hydrogen is different, but attachment for the central chiral atom is the same. Okay, attachment for the central chiral atom is, in this case C means the carbon is attached, in this case this carbon is attached. Okay, such situation if arises, then you consider the next atom attached to these elements or atom. Okay, therefore we have to consider the, in this case CH2, we consider the next attached atom is the, these are the next hydrogen and carbon. In this case next attached group is, or atom is the hydrogen. Okay, next attached group, in this case carbon is the more. Okay, these two groups are the same, but in this case hydrogen and this is carbon. Therefore in this case priority is given. Okay, therefore CH2 and CH3 is the more priority than the CH3. Okay, then bromine is the highest atomic number, then it's give the first priority, then your hydrogen is the last priority. Okay, according to the first we have decided the which attachment has higher atomic number. Okay, carbon has the 6 number 6, and in this case 35, and hydrogen is 1. Okay, therefore 35, no doubt it's more than these two groups, therefore 35 is the first priority group. Then 6 is the second priority group, but both are the same atomic number. Then we have to first, if such situation is arises, attachment is the same, then next atom attached to this is considered, or next group attached to this is considered, next atom is attached to this is considered, and which is having the higher atomic number atom is attached, then consider as the higher priority. Okay, therefore in between these two you consider this group is considered the higher priority than this. Okay, like that we have given the priority bromine, CH2, CH3 and the hydrogen. Okay, this is our second rule. If same attachment is attached to the chiral center or the stereo center, then you have to consider the next atom is attached, or next element is, or next group is attached to that particular attachment, and by observing this you can predict the which group give the higher priority. If third one is if your central atom is attached double or triple bond, then this double or triple bond is considered as like if suppose carbonyl is attached, then you can show this carbonyl like that. The oxygen is attached there. Okay, no doubt oxygen is attached. Okay, then second oxygen is attached. Okay, this is then in this compound you can attach the carbon and carbon. Okay, and actually this oxygen is attached, we have not shown in in bracket, that is parenthesis bracket, we have not shown. Okay, those group which is we consider extra attached, we have shown in a parenthesis, and that is pentone. Okay, these groups are called as the pentone group. Okay, that groups is called as the pentone groups. Okay, in this case oxygen has the only one valency, therefore we have shown the in bracket one carbon. Okay, for this oxygen we have not shown the attached our another valency because it's directly attached to this carbon. Okay, another example, by this you can clear all this concept. Nitrogen is there. Okay, we can show like that. See, nitrogen is definitely is attached, 3 bonds is there. Okay, that nitrogen, this is this, firstly we write this nitrogen. Okay, this nitrogen, and to this nitrogen we attach the carbons, and this carbon is in bracket or parenthesis, and this is the phantom. This bracketed term is the phantom. Okay, which its valency is not fulfilled. Okay, that bracketed or parenthesis carbon, its valency is not completed, therefore it's shown in the bracket. Okay, therefore the carbon is attached. Okay, that nitrogen is attached. Okay, and three bond is there. Therefore first bond, second bond, there is a nitrogen shown in bracket because extra bond we have shown, and another nitrogen we have shown in bracket. And to this nitrogen we have not shown the attachment of the carbon. Attachment of carbon we have shown only the this actually attached nitrogen we have shown. Okay, next example is the if C triple bond C is there, and we can show. Okay, this C bond C we have shown, and in bracket we have, firstly we have shown that, and then the first bond is shown, second bond and third bond. In this C extra is we have shown, and again C is extra is shown. Okay, and this parenthesis phantom, this 1 2 3 are the phantoms. Actually its valency is not completed, but this carbon valency we have shown the completed one. Okay, in this nitrogen 3 valency we have completed one. If suppose we have C double bond C, this can be shown like that. C double bond C means C, this C we have shown, and this valency for this we have completed, and next double bond is we can show like that. Okay, like that we double and the triple bond we can show when there is such situation is created where we have to discriminate which groups gives the higher priority than the other groups. Then we have to show like that way and try to find out its a priority. Okay, like that way third sequence rule we have seen. Okay. By using this 3 sequence rule, we have to predict the priorities in a molecule. Now, how to assign the RH configuration? There are the some rules is there. First rule is you have to find out the chiral center. Then second rule is you have to give the priority to different group is attached to chiral center, and then actually nomenclature will start. Then you, after giving the priority, you looks the molecule for like the way your least priority group, 4 priority groups should be away from the observer. You remember these 3 rules. First, you have to give the priority to the 4 different group attached to carbon. Then observe the molecule that side where your least priority would be away from the observer. If suppose we have one example is there. Okay, by using the example we can try to give the nomenclature. Okay, first is the configuration, how to assign R and S configuration. If you have the example, if lactic acid is there, okay, firstly we have to put the hydrogen at the fourth position, okay, bottom, and give the its priority. Okay, we find that it's that is the carbon one, that is the carbon one. Okay, 6, its atomic number is 661, and its atomic number is 8. Okay, first priority is given to the oxygen. Then in between these two, you have to find where you give the priority. Okay, this group is looks like that. Okay, same. Okay, in this case, carbon is next group attached is oxygen. In this case, these two groups are, these two attachment is same. Then the second rule you have to use, you have to find out the which next group is attached to this attachment. Next group attached to this is oxygen. Next attached to is the 3 hydrogens. Therefore, you have to give the priority to this second, third, and fourth. In this case, first, second, third, and fourth. Okay, therefore 1, 2, 3, and 4. Okay, your rotation is like that, 1, 2, 3, and 4. In this case, your rotation like that, 1, 2, 3, and 4. Okay, therefore your priority rotation 1, 2, 3 in first case is a clockwise. Okay, this is the clockwise. If such rotation is there, then your configuration is considered as, that is the rectus one. Okay, this clockwise rotation is rectus one, and this nomenclature for this molecule should be R. For second, your priority is the 1, 2, 2, 1, 2, 3. Priority is the anti-clockwise, that is sinister. And sinister means the anti-clockwise, and sinister for yes, you have given the nomenclature yes. Okay, now we have the actually we'll try to learn how to find out R configuration or yes configuration when your molecule is in Fischer formula. Okay, one example is there: CHO, OH, H, CH2, OH. Okay, that is your glyceraldehyde. Okay, first priority, you have to try to find out the priority. In this case, carbon is attached, hydrogen is attached. Okay, oxygen is the atomic number 8, therefore its priority is 1. Then in this case, CH2OH. Okay, H, and the OH. In this case, like that situation is there. Okay, in this case, 2 hydrogen is attached and 1 OH is attached, directly attached. These two groups, this attachment carbon is same. Then for find out the priority, you have to find out next group, next atom attached to this. Okay, next atom attached to oxygen is there. Hydrogen is there. In this case, hydrogen is there, but double bond oxygen is there. It means it is looking like one oxygen is there, and for higher its valence is completed, and other oxygen. Okay. Therefore, this carbon is attached to oxygen. Okay. According to third rule, double bond is attached to oxygen. Therefore, its priority is given to the aldehyde group. Priority is given to the aldehyde group. Therefore, your second priority to this group, third to this, and fourth. Okay. When you find out the R and S configuration in such Fischer projection, then we have learned that the 3 rules. That is, you have to give the first priority, and you observe the molecule in such a way that the least priority group should be away from the observer. Okay, therefore you try to put that hydrogen in at that position. Okay, is away from the observer. You try to, okay, firstly you exchange hydrogen with this group. Okay, exchange hydrogen with this group. Okay, firstly we exchange hydrogen is at the bottom. Okay, first try to add CH2OH and CHO, and in this case OH is there. Okay, we have learned in a Fischer projection formula. Okay, if odd exchange, okay, this is first row exchange, that is odd exchange will change the configuration. Therefore, if you exchange like first exchange is there, you have to exchange second exchange, you have to you have to consider the second exchange. Okay, there is a need to consider the second exchange. Always remember that two exchange should be there. Okay, if you put the fourth group at the bottom, then your work is not over. You have to again one of the change you should be do there, because the configuration is changed. Word exchange configuration will be changed. Okay, it's not same configuration. Therefore, again you can exchange any one group. Okay, you can exchange these two groups. Okay, or instead of these two groups. Okay, these two groups exchange. OH is in this case CH2OH, CHO as it is, hydrogen is there. Okay, therefore your first priority, second priority, and the third priority, and the fourth priority, your clockwise rotation is there, and your configuration is the R configuration. And this is one of the rule to find out the by using the exchange method. Okay, exchange of groups, you can find out the R and the S configuration. Okay, in this case configuration is the R. There is another method by using which we can directly predict the configuration in Fisher projection without exchanging. Okay, first case. Okay, in first case first, if the priority group is at vertical position, okay, or like that. Okay, priority group at vertical position, whether it is at that position or whether it is at that position. If such condition is there, then clockwise rotation. Okay, so anyone where present clockwise rotation. Okay, always rotation you have to do with the 1, 2 and 3, like that rotation 1, 2 and the 3. Okay, if suppose we have the such condition 4, 1, 2 and the 3. Okay, you have to not go like that. You have to go 1, then 2 and 3. Okay, like that way you have to go 1, 2 and the 4. 1, 2, 3 and the 4. Like that way you have to go. Okay, you not go like that. Okay, 1, 3. You have to always for 1, whether in between there is a 4, doesn't matter. 1, 2 and 3. Okay, if rotation is the clockwise, then you consider R configuration, and rotation is the anti-clockwise, then you consider the sinister, that is the S configuration. Let us take one example. If your configuration is like that, okay, fourth position, there is a 4 priority group. In this case is present at the top, 2 is present in this here, 1 is present here, and the 3 is present here. Okay, then you have to move from 1 position to the 2 position to the 3 position. Okay, such rotation is the sinister rotation, and that is configuration is the S configuration. Okay, therefore S configuration remains as it is if your position 4 or 3. If suppose 4 is present at the bottom, 3 is present in this position, then 1, 2, 3. Okay, like that rotation is there, and your rotation is the R configuration. Okay, the configuration you put as it is if your fourth priority group is at vertical position, and if your fourth priority group is present at horizontal position. Okay, fourth, if suppose like that condition is there, fourth priority is group present in the horizontal position, then if clockwise rotation is there, then clockwise rotation means R, then your configuration R changes to S. So you have to write R changes to S if your group is present horizontal, whether in this or in this position. And if your anti-clockwise rotation is there, then S changes to R configuration is there. Suppose take one example. If like that example is there, if your fourth group is present horizontally, 1 is present, in this case 2 is present and 3 is present. Your rotation from 1 to 2, 2 to 3. Like that rotation is the R, but your fourth group is present in horizontal, then your configuration changes to R to S. Okay, like that way, if horizontally your least priority group is present in horizontal position, then you have to change actual configuration. Okay, if your 1 2 3 rotation is if clockwise, then you have to change R changes to S. If it is anti-clockwise, you have to change to the S changes to the R. Okay, like that way, you can predict R configuration and the S configuration. Important thing in this assigning the RS configuration is you have to find out the which group is having the higher priority and which group is the lower priority. This is challenging task. You have to find out the sequence. Then you can predict the any configuration of the molecule. Then without giving the priority, it is impossible to predict the R and S configuration. Thank you very much. This is all about R and S configuration.